So guys, we are here at the stall of IIT Jodhpur and we are having with us Professor Prodyut He is working as an Associate Professor IIT Jodhpur. So sir is going to tell us about the thermal management of batteries. Actually,
it's not thermal management of batteries, it is thermal energy storage. So
thermal energy storage.
Thermal high temperature thermal batteries.
So, okay, so it's something related to PCM because we talk about
yes,
PCM, phase change materials to store the thermal energy.
Yes. So what we are doing is we are storing the energy in the form of latent heat at high temperatures. So the phase change materials that we are using that have a melting point ranging from, if you see, 310 degrees Celsius approximately to 150 degrees Celsius. So we are storing the latent heat at high temperature.
When we talk about PCM, sir, there are so many phase change materials available. So based on your research, what you can suggest to the kind of industry people also?
That depends on the application part. That depends on application. So this phase change material I am choosing because here the application requires temperature that
normally suppose if you will take a case of evacuated tube collector, yes, temperature range of 300 to 350 degrees Celsius. So what will be the best phase change material?
No, but evacuated tube collector, it is for what application that you have to understand.
Okay.
Right. So there you have through the tube there is a heat transfer fluid that is flowing.
Yes.
And that heat transfer fluid is subjected to concentrated solar energy.
Yes.
That is getting heated up.
Yes.
But it comes after that. So that energy is either supplied to a CSP power plant,
yes,
or process heating. For many other applications you can use that heat. But for instance, if you want to use that heat during the hour when sun is not available, at night if you run the thing,
yes,
so and you have excess amount of energy, what happens in many power plant, you have excess energy and then you defocus, you do not use that energy. Okay, so that excess energy in fact you can store in these batteries, and at night, or if there is a cloud cover during a daytime 2 hours of cloud cover,
yes,
you can tackle all those problems with this stored energy.
For cooking purposes also can we
definitely it is see the solar cooker currently it's a proven technology,
yes,
but people have not accepted it,
yes,
right? The reason, the cooking time, if you look at, generally the cooking time is either early morning by 10 o'clock your household cooking is done,
yes,
and the next stage of cooking starts in the evening. Okay, but the solar energy is available 10 to 4 o'clock.
4 o'clock, yes.
Okay, most of the people do not cook during that time,
yes, yes,
or even if you want to cook you have to stand in the sun,
yes,
right?
Yes.
So now with this technology you can store the energy when it is available, and since you are using heat transfer fluid to supply, you can directly supply this energy to your kitchen, where you have a different kind of stove which is not burning fuel, but this heat transfer fluid is taking energy from the battery and directly supplying it to the kitchen in a heater, and you can cook it. And by controlling the flow rates you can actually achieve different effects of cooking. And the cascading concept, since you have different phase change material used, you can use it for cooking for instance frying, it requires temperature above 250 degrees Celsius. Okay, boiling, cooking curries, all of them, or making chapati, all of them requires different level of temperature.
Actually it is good, because if you want heat,
yeah,
it is good to directly use that heat into producing
exactly.
heat only.
And this will be excellent for any community cooking purpose. If you have some canteen, maize in different places, it will be an excellent solution.
What are the further research scope actually, or what you can say future scope available in this area if someone wants to do research in that area?
Okay, so the major issue I will tell you is the heat transfer fluid that we are using to collect the energy. This heat transfer fluid, most of them decompose above 400 degree. Maximum you can go up to is 425 degrees Celsius. Okay, so that means if you want to have utilization for our conventional power plant, typical steam temperature 550 to 600 degrees Celsius, if you want to use that kind of temperature, you cannot use this heat transfer fluid.
Yes.
So for that high temperature you have to come up with some substitution of this heat transfer fluid. So of course you cannot use this fluid, either you have to heat it by air, but again for air, since the thermal conductivity is small, your convection coefficient also goes down substantially. The other possibility is, there can be granular flow where the solid material can be used as the heat exchanger. The granular material actually behaves like fluid when it flows with gravity, and then some conveyor belt mechanism. So alternative pathways needs to be looked at, and there are plenty of research opportunities.
When we talk about solar energy conversion into some kind of heat energy for cooking purposes or any other
that is
process heating,
that is best, because
yes, that is best,
because you get 60 to 70% efficiency.
Yes.
Because in PV, when you are generating electricity at the beginning itself, 12 to 15% on field, frankly speaking, it goes 8 to 12% efficiency, and then again converting into heat doesn't make sense.
I think largest solar cooking system is there in Mount Abu, Rajasthan only.
Yeah. Yes.
So what do you feel, sir? Why actually that thermal system fails in comparison to
but
the
that
PV
Mount Abu
technology?
system doesn't have this storage.
Yes,
they have steam storage.
Yes.
But that is limited, because steam storage means 100 degrees Celsius, that kind of application. You cannot make chapati and other things.
Yes.
Okay. So this technology can you can cook all types of things.
Yes.
And at the same time, you can supply this heat directly inside the kitchen. You don't have to stand outside and cook.
My last question to you, sir. What about if you will compare this technology with the PV cells, photovoltaic cell in generation of electricity?
Right.
Actually, government also they installed some plants, thermal plants.
Right.
I think there is some planting.
So actually, this entire idea originated from there as well. See, PV is very good, and if you compare the price, etc., it is now at par with conventional power.
Yes.
Right. Somewhere around 8 rupees.
Yes.
Per unit. Now, PV, the major challenge in PV is, if you want to use PV at night, you have to install those electrochemical batteries.
Yes.
And these batteries are very, very expensive.
Yes.
When you are talking about megawatt level or gigawatt level. On the other hand, for solar thermal, initial installation is high, that cost is high, but the storage cost is much lower than this electrical storage, thermal energy storage. So one solution can be the hybridization of PV with thermal. So during daytime you use PV energy, and during daytime this thermal energy you do not use it for running your power plant, but store it. Okay, and night this stored energy can be used to generate power.
Great.
So this hybridization probably will give a much better solution, and you can run things with renewable energy 24/7.
Thank you very much, Professor. Very great work, actually marvelous work was carried out by your team. Thank you very much for sparing your time.
Thank you.